Okay guys, so this is just going to be a really quick review of the trigonometry we learned in year 9 with right angle triangles. So if we've got a right angle triangle here, we need to remember that the side across from the right angle triangle is called the hypotenuse. Okay, and we label the other two sides relative to the angle that we're working with. So for example, if we were working with this angle here, then the side that's opposite that angle is called the opposite side. Okay, and the one beside that angle is called the adjacent. Okay, and from that we get our three trig ratios. So our trig ratios, we remembered using the word SOHCAHTOA, and that told us that the sine of the angle, or the sine of theta, is equal to the opposite over the hypotenuse. The cos of theta is equal to the adjacent over the hypotenuse, and the tan of theta is equal to the opposite over the adjacent. So we'll just look at a couple of problems just to remind ourselves how to use these three trig ratios in order to solve problems with right angle triangles. So in this first one here, the first thing you always want to do is take a look at the information that you're given. So we know this angle is 27 degrees. We know that that side there is the hypotenuse. And then the side that we want to find out is adjacent to the angle that we're given. So that's the adjacent. So what we want to use then is the ratio cosine, because we need the adjacent and the hypotenuse. So just writing out the cos ratio, we get cos of theta is equal to adjacent over hypotenuse. And then filling in what we know. We know that the angle is 27 degrees, and we know the adjacent is x, what we want to find out, and the hypotenuse is 11. Okay, to solve for x, we need to multiply both sides by 11 to get 11 cos of 27 is equal to x, and then putting that in your calculator, we get that x is equal to 9.8, and that's in centimeters, rounded to 1 decimal place. So don't forget to check that your calculator is in degrees, otherwise you're not going to get the right answer for these. Okay, let's try another one. So in this one here, our angle is 53 degrees. Then we've got the opposite side here, and we want to find out the adjacent. So the ratio we need to use is tangent. So tan theta is equal to the opposite over the adjacent. Fill in what we know. Theta is 53 degrees. The opposite is 71.3. And the adjacent is x, what we want to find out. Okay, so now what we have to do is we have to multiply both sides by x. Okay, and then to solve for x, we need to divide both sides by the tan of 53. So we get x is equal to 71.3 divided by the tan of 53. Okay, and then we can just put that into the calculator to get x is equal to 53.7 centimeters. Sorry, that's a bit messy down there. Okay, so we'll do two examples now where you need to find out the missing angle. So again, we're going to label our sides first. So we want to find this angle here, theta. The one across from it is the opposite, and then here we have our hypotenuse. So now we want to use the sine ratio. So sine is opposite over hypotenuse. Now this time we're looking for theta. Our opposite is 1 and our hypotenuse is 2. So hopefully you remember to now solve for theta, we need to use the inverse sine button. So what we're trying to find is the inverse sine of a half, and if you put that into your calculator, you'll see that theta is equal to 30 degrees. So for this second one here, I'm going to start by labeling my sides. So this is the angle I want to find out, theta. 2.5 is my hypotenuse because it's across from the right angle. And then this would be adjacent to the angle we want to find out. So the ratio we need to use is cosine. So filling in what I know, the adjacent is 1.5 and the hypotenuse is 2.5. So to solve for theta, I need to do the inverse cos of 1.5 divided by 2.5. Into my calculator, rounded to the nearest degree, I get that theta is equal to 53 degrees. Last thing we're just going to talk about are some applications of trigonometry, and we need to just remember that if we're talking about an angle of elevation, what we're talking about is the angle that we get from the horizontal or from the horizon, and then the angle of depression is the angle of the sort of downward sloping line that we get from the horizontal. So an example of that, here we have a helicopter that is flying at a constant altitude of 91 meters. So that means it's 91 meters above the ground. This helicopter sights a landing pad at an angle of depression of 16 degrees. So we'd assume the landing pad might be somewhere over here, our landing pad. And the angle of depression is 16 degrees. So that's the horizon, or that's if like the helicopter was flying straight, but it needs to go down at an angle of 16 degrees. So that's going to be 16 degrees there. Okay, now we need to know how far the helicopter needs to fly to be directly over the landing spot. So we're saying like how far does it need to go from there to over here? So it's directly, well, it doesn't look directly on my diagram, but so it's directly over that landing spot. Okay, so what we want to find is this length x. And then we know here that the altitude of the helicopter is 91 meters. Okay, so what we have here is a right angle triangle. This is a right angle. There's our angle. We've got 91 meters. That's our opposite side, and x is our adjacent. So we need to use tan to work this out. So we would do the tan of 16 degrees is equal to the opposite, which is 91, over the adjacent, which is x. Okay, multiply both sides by x. And then to solve for x, we need to divide by the tan of 16. Okay, and then you can put that into your calculator. And to one decimal place, we get x is 317.4 meters. Okay, which tells us the helicopter needs to fly 317.4 meters. Okay, so that was a sort of whirlwind of what we did in year 9. You need to try some practice questions now from exercise 4A, B, and C according to your unit plan.